Yeah, so thanks everyone for turning out. It's a great turnout to talk about Ipython. It's kind of a nerdy topic, but I'm glad you're all interested. I know I am. So, my name's Casey Stella, and I'm going to be talking about Ipython Notebook as a unified data science interface. So, I give a lot of talks, and I like to go to Summit. This was our first European Summit. But I talk a lot about data science, and a lot of times it's very algorithmic, right? We're talking, use this technique, and if you went to the meetups before a summit, I talked about a technique. This is really about like the practice of doing data science and the interface and how you actually, how you interact with doing a data science task on Hadoop, which is not something that's really been written about a lot. So who am I? I'm a principal architect at Hortonworks. I've been there for a long time now. I work primarily in the data science end. So I have a software engineering background and a math background, which kind of merged into a scientific programming background, which eventually merged into this data science thing. Right? Before we were just called, scientific programmers. Now we're data scientists. But I did most recently I've done a lot of medical stuff. Right, I worked in the oil industry, I worked at Oracle, done some math, it was cool. Wish I could do more. So, what do we talk about? So, Hadoop, it's such a great environment for data transformation. And you see a lot of the use cases, like the ones that everyone gets started with, or ETL offload, or whatever. But every ETL offload project, they'll bring a data scientist in, so we want to talk about the next use cases. And they always have data science use cases, because they always want to gain more insight from the data. But it does pose a challenge because while ETL developers are mostly comfortable sitting inside of a terminal, SSHing into a box and writing pig, sometimes they're not, but a lot of times they are. Data scientists have become used to a certain kinds of environment, and every data scientist has a different way that they want to work. So what would be nice is a unified environment where you don't have to bounce around. I need to write a pig script here. I need to write, Hive queries here. It would be nice to have one place. So we need a single system where both data transformation and data science algorithms can be expressed naturally. When I say data transformation, I'm not talking about doing your routine ETL, but when you're doing feature extraction as a data science task, that is a kind of ETL. Right? You need to be able to join tables. You need to be able to do those kinds of things. That's why SQL is used to DSL that we use on a daily basis. At least a lot of us do. And it can be challenging to have one single place for that. So it also needs to be done inside of a popular language for data scientists. You go to an ETL developer, you go to your basic software engineer. They're going to be comfortable writing in Java, right? I like Java. I write in Java, whatever. But a lot of data scientists would prefer in a scripting language like Python or R, right? Particularly for this talk, we're going to talk about Python because I think you can make a pretty good argument that Python is one of the better supported languages right now in the Hadoop environment. It kind of bridges that. You also need a system to represent the output. So data science in and of itself, the analysis is great and all, but you only get funding if you can show results, right? And showing results are generally showing graphs that go up and to the right to people, who write a check, which is generally not another data scientist, right? I mean, maybe. I've not interacted with them if they do. So it requires some custom coding, right? Often you have to generate graphs and stuff like that. So what we would like is a unified environment. And I think we can make a pretty good case that a notebook environment with Python, with Spark, is actually not a bad way to be. And I know you talk about Spark, you're going to hear about MLlib. I'm purposely not going to talk about MLlib because I think it's great. It's not that I don't like MLlib, right? Don't get me wrong. I talked about MLlib earlier. But I want to show how you can do some bread and butter data science. More along the lines of data analytics even, right up to the edge of data science. Without necessarily relying on, these heavy algorithms. So what are the components? A single environment. I think Apache Spark does that, right? You can interacts with SQL, right? It can reach out to other languages to provide that bridge. comfort, right? It has Python. It has first-class Python bindings, which I think is important. And it's not this, janky Jython stuff where you can't use scikit-learn or anything like that. No, you can use real Python now. You can also do this in Pig, by the way, recently. Right? You can write Pig UDFs. But it's just so nice because it also has strong SQL integration. You can if you land your data, if you're interacting in an enterprise environment, they'll want to land their data in a place where they can track it, right? And a part of the tracking story right now in Hadoop, at least for relational data, is landing in Hive, right? I can track changes, et cetera. So that's part of a lot of the governance stories. So interacting with that means that as a data scientist, you need to go get the data. When they say landing data in a data lake, they're not talking about just like landing in HDFS most of the time. They're going to try to pin up Hive tables and things like that. So you need to be able to interact with that. And it can. And also simple analytics are very powerful with SQL. There's some weirdness right now with Spark SQL and the Hive integration, but it's getting there. We'll talk more about that. The ability to visualize and report summary data, right? You have to be able to generate graphs. And I think Ipython Notebook is a really strong way to do that. So you have on the one end, you have environments that have limited, not limited capabilities, but they're very focused on providing these kinds of things, right? On providing these kinds of images, right? And on the other end, you have where you're writing everything custom inside of an editor somewhere or whatever, and there's no real interaction there. You're not building up documents. And kind of sitting in the middle is Ipython, which I think it does very well in that middle place where you're writing a story, right? Okay, so Spark. What is Spark? Everyone probably knows what Spark is, but if you don't, I'll go over it briefly. I'll touch on the key points. Spark is a system for processing data inside of Hadoop. It has an elegant, rich, and very usable set of core APIs. And it's not just, the core APIs are not just map and reduce like we were all used to back in the day. You have some relational primitives as well. You can join data, you can do outer joins. It's not SQL, but it's kind of reaching toward that. There's expansive set of ecosystem libraries like MLlib, which is one of the more interesting large-scale machine learning projects in the Hadoop ecosystem. And you have Hive compatibility where you can reach into the metastore and interact with your data. And also, which I think is one of the more important things, is really mature Python support, right? All of the ecosystem projects, or at least most of the ecosystem projects inside of Spark have bindings to Python, right? You can call MLlib directly from Python. Okay. So the core ideas, in the core API there is datasets are distributed and resilient. They're called RDDs, right? So datasets can automatically be rebuilt on failure. So there's this notion of laziness where you have your data and you have your transformations in the data, a tree of transformations in the data. And if one node fails, you just have to recreate the data that was on that node. Which isn't necessarily as important to the data scientists in the crowd, but other than to say that you're not going to lose data, right? Transformations are in parallel. It's a distributed system. It's a parallel system, and they support some relational primitives. Okay, so the important thing about the Spark about the Python bindings here is that it supports the standard C Python interpreter, right? As well as reaching out into the ecosystem. And the Ipython Notebooks comes supported. There's a lot of notebook products out there now. I'm not necessarily saying that Ipython is the only one. It's just that, in the documentation of Spark, there is documentation about Ipython. So that's the one that I'll show you today. Okay. Let's talk about the SQL integration. So I'll show you a demo later on, and I was going to write, what I wanted to do with a demo, I wrote a 5-part blog series. I was going to kind of distill that into a demo. And I wanted to show the same code implemented in SQL as well as implemented in Spark to kind of to see those two, how those two things related, what the performance implications were, whatever, blah, 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 blah. A fairly complicated algorithm, but not a super complicated algorithm, In Spark SQL, it never returned, right? But in the core APIs, we were able to get through it. Why is that? It just means to say, it's not to say that Spark SQL is bad, it just means to say that be aware that it's a work in progress at the moment, right? But there is a place for this in doing a lot of your analysis, because a lot of times what you want to do is you want to take this data and do summary statistics on it. And you'll see an example of that later. Okay, so on to the demo. I took, as part of the Healthcare Act in the United States, we've opened up some data sets. We're trying to be more transparent about, in particular, physician relationships and with people who provide the money, essentially, with other corporations. So they released a data set as part of the Social Security Act for all the doctors that interacted with our Social Security system. They had to report all of their relationships with all the different corporations out there, and how much and for what reason that each instance was given. It's broken down into each individual instance. So a doctor, if a company bought a doctor dinner, they would have to note it, right? It's kind of interesting. It's a very interesting data set for doing sort of fraud analytics, right? But the idea here is that we'll use Python and Spark to kind of explore this data set. Now, a lot of people in the room would say, this isn't really data science, it's data analytics more. But I think data analytics is on the way to data science. You have to understand the data as a necessary prerequisite to data science. And I think outlier analysis, which is what we're going to do at the end, fits well within that. Okay, so this is the Ipython Notebook. There's some preliminary stuff here. I'm not going to go through the code. I'm not going to bore everybody to go through the code. It's all on GitHub. You can take a look at it. It's also broken down into a blog series. But some of the nice things I want to point out along the way. Okay, so you can actually write functions here that are reusable, which is nice for printing tables and generating bar charts and such and so forth, right? So one of the first things we do with any data set is we look at sort of summary statistics about it. So that means generally interacting with the data in a way that SQL was intended to. And since SQL was intended to do this, we'll use SQL for this kind of summary stuff. So I can do, first off, I want to know how many rows are there. Well, there are about 2.6 million, and I did a select count star, right? I'm pulling this data from Hive, right? So before I ingested this data into HDFS, there's a small amount of ETL required, but the point is it's published data as far as the data science. If I put my data science hat on, it's published data on the cluster. And by the way, this was all done inside of the Hortonworks sandbox, so it's small data. It's only 2.6 million rows. Okay, so next we want to kind of break down how many payments based on reason, right? So how many individual payments were there broken down by reason? So there were a lot of food and beverage purchases, right? Far more, in fact, than most anything else, right? Next comes travel and lodging and education, and then kind of down here consulting fees. Okay, so, and you'll see it was a simple SQL statement, right? Next, we want to total by specialty. So I'm being very specialty focused. So I want to see what the breakdown is by specialty. How many payments, and what's the percentage of the total payments? And I'll do the same thing. So osteopathic physicians of the bone, which makes sense because this is the Medicare data set, which is generally for the elderly, right? So there's a lot of joint issues and things like that. Man, urologists are coming in last. That's sad. Too bad for them. All right. Now, what about the actual total amount of payments, right? You'll see broken right up at the top is orthopedic surgery, right? So that's joint issues, generally bone issues. So when you have your hip replaced, So anyone who's worked with medical data, at least in the US, knows that we're getting killed on old people falling, right? That's like, all the press is about diabetics, and that's important, right? People have diabetes too, but in terms of like the amount that you actually pay, that the insurance company pays and how much you're getting paid, like it's old people falling. And as a result, they're getting, these orthopedic surgeons are have a really strong relationship with physicians, or with external companies, because they do a lot of the consulting. They'll do consulting. They'll have inventions that they license out. So a lot of the data the vast majority of the actual payments are orthopedic surgeons. Okay. So that's kind of what, now we got the feel of the data, right? We understand we can do these simple statistics. Let's do something more interesting. Outlier analysis. So what I really wanted to know was, is there anybody, like, outlier analysis might feed examples of possible fraud. That's the hunch that I have, right? So I want to do some outlier analysis. Why don't you look around, like, how do you do outlier analysis? There's lots of different ways. Most of them are pretty simple, right? Some of them are very complex. They range from simple to complex. I try to pick something in the middle, something that didn't use machine learning, something more statistical, and something that was computationally relatively intensive, right? So I went with, I went to the trusty Engineering Statistics Handbook and saw what they had to say. And the standard deviation approach is very standard, but this is non-normal data. So what they said was, there's a technique called the median absolute deviation. And it's kind of like interquartile range approaches, where you take the standard deviation, you look in the 75th percentile, or blah, 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 blah. Right? But particularly, it's good for data that's not normal, right? So this particular, like, these payment data are just absolutely not normal at all. So, but I like how they phrase this. However, they are not particularly strong for robustness of efficiency, which means it's computationally inefficient to do. Because you got to do a lot of medians, and medians are a little bit hard to do, in the sense that you're going to have to compute the medians, and it's not a streaming computation that you can do easily without having to estimate. But let's talk about what it actually is. So you generate a z-score, right? It's with a threshold, just like you do with interquartile ranges. But the z-score is based on this median absolute divergence. So you take the median of all the differences. So what I'm going to do is I'm going to only consider the outliers within a given specialty. So I'm going to treat, if you're a specialist with this other, if you have a set of specialists there, if everybody within a given specialty, I want to make sure they're an outlier within their group. And then I'll take the biggest outliers across all of them, and I'll report on them, right? Ordered by the total amount of money that they got. Okay. So, but what that means is, for each of those groups of specialties, I need to compute the median difference between every point and the median of that group, right? So it's a median of a set of medians. Okay, so it results in, so there's some helper functions here with Spark. In particular, I have a reservoir sampling implementation there, which you'll see later. But what I'm going to do is I'm going to take a SQL query. I'm going to take the output of that SQL query, and I'm going to pass it right into Spark. So this is an example of mixing the primitives. So you can mix the systems. So you can do a lot of your heavy lifting in SQL, and then take the output of that, and then further filter or join the output of that, et cetera, or then do other kinds of processing, which isn't something you see a lot talked about, but it's actually very powerful, I think. Because a lot of times you look at the Spark API, and it's further, I mean, it's robust and it's nice or whatever, but you're thinking to yourself, man, I'm going to have to join, and it's a pain in the butt. You know, because I got, you know, I want to do a lot of different kinds of joins and filtering, et cetera. But you can do a lot of that here in the up front in SQL, and then take the output of that and do further refinement where it makes sense. So mixing that mode is very nice. So when I talk about mixed mode computing, that's what I mean. You're mixing Spark with SQL, but you're also mixing which you'll see later, you're also mixing actual Python functions. So you define the Python function up here, you can pass it in, right? And if you've ever tried to interact with like Pig or Hive as a UDF, you'll notice it's a pain in the butt because you got to go out to an IDE, you got to build your UDF, you got to compile it, you got to put a jar file somewhere, or you have, it's a big, and it's like a completely separate file from the actual core logic. It's right here, right? I'm defining functions that I'm using inside of, they're getting pickled and sent across the cluster seamlessly. Okay. So I put a lot of comments in here. I suspect you'll probably read them later. But it's fairly easy to do, but it's computationally intensive. You have to go over the data. There's a lot of medians to compute, right? And this is just basic Spark. And it's about, 50 lines of Spark. I wanted something that was a little more difficult in the trivial example with standard deviations, but not as intense as some of the other more intense approaches that I've seen out there. Okay, so let's actually look at the data. So what we're gonna do is we're gonna look at it by we're gonna look at a couple of them. All right, gifts and food and beverage. Because I'm fascinated that there's like so much food and beverage given to doctors. Because people that buy my dinner, I'm just curious as to why they're buying theirs, right? And how much. All right, so gifts. This should be the one that's like rife with the potential for fraud, right? And you see, so I use a synthetic identifier for the physicians instead of their name. Originally, when I did this, I actually had the name right there, but I thought, ooh, no, I'm not gonna like make a hit list of potential fraud candidates. It's like, no, this is a dull blade exercise. I don't want to get anybody in trouble. But dentists come right up at the top. All right, so here's so I was talking about images, right? To kind of get a sense of this. So I plotted the outliers with a random sample of the inliers, right? So I'm not putting all the points in the plot. These are the kind of things you have to worry about, right? When you're dealing with big data, you have 2 million points, right? You don't want to put 2 million points in a plot. Ipython Notebook will crap on you. So you sample it out and you say, okay, I'm going to give a sample of inliers just to kind of show the distribution, and I'll point on the plot where the outliers are. Look at that bad boy right here. Man, someone's getting some gifts. All right, so I looked this one up, actually. Dentists are like all over the dentists are getting some gifts. If you ever want to get gifts from people, be a dentist. That's all I have to say. This is a dental chair manufacturer in Alabama. And this is giving $56,000 in gifts to a dentist. That's not chairs, by the way. The gifts are not chairs. There's just like extra, gift baskets. They get, like I hear if you go to the Grammys, you get very expensive gifts. But like if you're, I didn't know the dental chair manufacturers did this. But dental supply companies, dentists are getting a lot of gifts. And you can see, it kind of looks, it definitely picked out what I would consider the outliers there. And it's nice. It's a nice log. It's nice to get validated. It's nice that the Handbook of Engineering Statistics still has valid ideas, even though it's like very manufacturing statistics focused. But it worked very well for this, I would say. All right, so moving on, I want to talk about food and beverage because I found this fascinating too. Someone's getting $68,000 in food. That's the district. Like, look at that. If that's not an outlier, I don't know what is, right? And let me just point this out. This isn't like $68,000 across the year. This is one instance of $68,000. I don't think Hortonworks paid $68,000 for the food for this conference. So I want to point that out. Like, someone's getting a lot of money. So if you look at it, so I'm damning these guys or gals without a lot of cause. So if you look at it, the Wall Street Journal actually did an article about this data set, and they pointed this out. I don't know who was doing their statistics, but I wish they looked at my blog series. It would have been nice. So I did a lot of the other ones too. There's some other interesting stuff in this data. Fascinating data. But anyway, so they said, you know, they actually called up the guy, the physician here, who got the $68,000. And they're like, what is going on? Like, how did you spend $68,000 in one meal? That's just crazy, right? It must have been like some Cristal bottle service at a club or something. I don't know. He was like, no, I didn't get $68,000. So it's bad data, ultimately. So a lot of this outlier analysis, you could think of it as almost a data quality check. You should be, let me put it this way. As a data scientist, data quality and data science fit hand in glove. You should be doing outlier analysis. You should be doing this stuff. Not all of this is fraud. A lot of this is just plain old bad data. But these are the kinds of insights you hand to a manager and you say, hey, look, this is bad. And here's the reason why. Because they're going to understand, well, they may understand, they're not going to understand distribution plot, but they'll understand that this is red, and it's way over here. And all the other ones are blue, and they're way over there, right? This is my point. And this is why this is a powerful approach, I think. And it's also very simple, right? This took about, 3 hours to sit down and implement after reading the algorithm. It's medians, it's not that complicated. At any rate, I pointed out the part about Spark, about Spark SQL. As things get better with Spark SQL, as stuff gets more mature, it will be more and more possible to push, to do more and more processing inside of Spark, Spark SQL. The one thing I am a little bit concerned about is what I would love is better R support, and to actually have maybe an Ipython notebook or a notebook system with R and Python, and you can mix and match and use the right tool for the job. It's the Unix philosophy, right? Use the right tool for the job. Some algorithms you're going to find in R, some you're going to find in Python, etc. All right, I'm going to stop there now. I mean, I'm a little early, but I'll ask if you guys have any questions. Yeah, please.
Your last note, you said it would be great to use Python and R.
Yeah.
And you're using Jupyter Notebook.
Yeah, I know, right? I should be able to. So when I first wrote this, Jupyter hadn't really, like when I did a pip install IPython, that's what came up. Right, before I do pip, it was IPython. So now, yeah, I guess so Jupyter does have some support for R. So the trick actually isn't that Python, the notebooking systems don't support R. It's that frickin' Spark doesn't support R very well. In 1.4, they finally got Spark R into mainline. So, but all that means is you could do this algorithm, but you can't call MLlib from there, right? Which I want all of it in one, right? I want R and Python and Java. And then my life would be happy because I wouldn't have to look at an algorithm and say, oh, I can't use that because it's R. Or if I have to use that, I have to go write a MapReduce job again. I'm so over MapReduce. It's like so last 2 years ago, 3 years ago, whatever. Anyway, that's a good point, yes. So Jupyter's really cool. There's some other notebooking products out there too. There's one in Apache, Zeppelin, I think, which is kind of gaining some interest since it's in Apache. Anything else? Yeah.
I read about the data frame concept in Spark.
Yeah.
What's the status on that, and how do you see that? Seems to be fitting in very nicely with the sort of the pandas stuff.
Yeah, so I love it. At Hortonworks, like a year and a half ago, the data science team was kind of kicking around, what will we like, right? This Spark wasn't even part of the distribution yet or whatever. It's like, we really want a virtual data frame. And sure enough, the Databricks guys must have had ears in the office in San Jose. But like, sure enough, they created. I love it. I think it's fantastic. It's definitely what they're going to build. That's the abstraction they want to build on. It fits very well within Pandas, which I'm a huge fan of, right? So I'm +1. I think that the Spark community is behind it, and I think we'll find some. I think it's the right abstraction too. So I mean, I like RDDs. Don't get me wrong, but Data frames are just so much more powerful, I think. The abstraction's at a higher level, which I like to, at the level that I like to work at. But yeah. Yeah. Yeah, wait for the mic.
I hope I'm not off topic with my question, but I feel that Python is a very good tool to do prototyping.
Mm-hmm.
So, but once you have a model, let's say you have a model for a recommendation engine which you have tested in Python and with,
Yep.
and you want to port it to production, and it needs to be scalable, and
Yep.
it needs to be stable and fast. How would you do that?
How do you do it? Yeah. All right, that's a good point. So I've heard this argument a lot. I used to work in the oil industry, and if it wasn't written in Fortran or C, it wasn't production ready, right? So we would do a lot of our prototyping in MATLAB and Python, whatever. It was moving to Python. I think it depends on the algorithm. Seriously, I think it depends on the algorithm, right? Some stuff, it depends on how you write it. Like if you're saying that, yes, on a single node, you write this in Python, then absolutely not production ready. But if you're doing something like this that is distributed out, you're using many, many nodes, I think it's less of a problem, actually. I think these kinds of systems, if you write them distributed from the get-go, I think the challenge that we have as data scientists is what we want to do is we want to pull a sample, we want to run our algorithms, we want to make sure they work, and then we want to say, all right, production team, implement it in a way that's not going to take 48 hours to run 24 hours of data. Right? I think that's the challenge. We have to get out of that mindset. We have to start looking at this stuff distributed from the get-go. And doing this, I mean, this is a small data problem, right? But doing it with Spark, doing it with the tools that distribute out, that scale out, ensures that I'm not going to accidentally write something that's going to only work on a single node. And as a result, I had to, here was a challenge. Median's relatively hard to do, and there was no implementation of streaming median available in Spark. So what did I have to do? I had to make sure that I segmented by I had to segment by specialty as well as reason. So I had a smaller set. But that smaller set was distributed across the cluster. And yeah, maybe it took 7 minutes to run on my 2 million data points or whatever on my laptop, but assuming that I am actually working in a system that's not just open data, it should scale out linearly. There's nothing about this that shouldn't scale out linearly. So as long as you make sure that your algorithms are scalable from the get-go, I think it should be okay to even use Python. I mean, don't quote me on that necessarily. You might fall apart. Don't come after me. I'm in the US anyway, so you'll have to get on a plane, and that's inconvenient. Yep.
I'm not familiar with Ipython and Notebook. Is this tool suitable for publishing reports in organization, or just for prototyping and exporting them?
It's a good question. Yeah. So I think that your environment, okay. So in determining a direction, as a data scientist, here's what I always get caught up in. So I work in the consulting wing of Hortonworks. I like to make sure that I actually have a client where I'm actually doing data science, not just talking about theoretically doing data science when I come to these kind of talks. And here's where I always get hammered on. I'll do the work, and I'll get it to my satisfaction, and then I'll have to go back and write documentation about it and generate a report. Because guess what? They don't care that I have a CSV file that looks right? Or I have an F1 measure that looks right. It's that they want that report so that they can snip this out and put it in a PowerPoint deck. This means that you're kind of generating your documentation and the reasons why along the way. Can you hand this to an executive? Well, no. I mean, it's got a bunch of code in it. Lord have mercy. I get fired in 10 minutes. No, but here's what you can do. You can take excerpts of that. It's already, all the collateral's there to build an actual report. So it's kind of doing half the work for you, I think, which is nice. So to answer your question, it's along the way. You get a little bit more collateral than if you just have a bunch of text files in a home directory somewhere. But you don't get the full report right there. But you also are able to generate the images, which I always find myself having to do, right? Which is kind of a pain in the butt, because I'm going to have to write Python to generate whatever images I need to write. I generate for my report. Yeah.
One more question, how to deal with changing data sets? I mean, when data
Yeah.
flows incrementally,
Yeah.
like page
How-
clicks.
How does anyone deal with changing data sets? We cry. It sucks. Right? That's the problem with, I mean, that's the problem with Hadoop. As you get more data changes. You have to keep yourself updated. It's the same as any other code. I mean, it doesn't fix that problem, but it also doesn't make it any worse than it is before. Like all of a sudden your Python notebook doesn't work anymore because the data sets change. Hopefully, one of the reasons why you're using Hive, hopefully, you know, you aren't removing columns or there's some migration path forward, et cetera, and in which case your prototypes, if you're going to continue to keep them up to date, have to exist there. The other thing is you snapshot that. You can save that as an HTML, or you can save it as it is now and not actually run it. So you get to see what it was before. Yeah.
How do you deal with distributing packages across the cluster?
Aha!
If you read a new paper and you want, this awesome new thing that's
Yeah.
really hot, how do you deal with that?
So now you've touched on the problem, on a problem that I keep talking to the Hortonworks engineers about. Here's what I want. If I'm allowed to, so let me answer your question, then I'll tell you how I would like to solve it, but I can't solve it yet. Maybe you guys can vote on a Jira or something at some point. There's not a great way, because what you want is you want scikit-learn version X, and he wants scikit-learn version X+1, and he wants pandas version, Y. All of your different data scientists are going to want the newest, sexiest algorithms, right? So or they're going to want something stable over here. Right, those are contending problems. So now you have a problem of actually, you have to distribute the packages across the cluster because it's running local to that node. And if you have a package that's not on the node, it's not going to be able to find it, and it's not going to be able to run, and that stinks. What I would love to do is have a system where you can build a Docker image, and you can run that within the context of the Docker image. So I can build a Docker image for my special Docker image as part of the, when I create the executor, I can say, executor, use this Docker image and execute all the code inside of that Docker image, and it will manage and push it out to the cluster. There's some thought about a Docker integration for containers and Yarn, just sort of in general. I suspect that'll be, before this is getting used extensively, that has to be solved. But I'll say this, there's also contention at the other end of the spectrum with IT. IT hates that idea. They hate me. I go into clients, they're like, no, stop saying all these things, right? They're like, no, I want version X. I want to standardize on version X, and when we have to upgrade, and I want to use it using Yum and blah, 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 blah. No, man, I mean, there's the natural contention there, and that's going to have to, that's an organizational challenge, and each organization has to figure that out, where they are. And I think Docker is actually not a bad solution for that. You have your base package that IT manages, and if you want to try out experimental stuff, you can run it inside of a container, right, where you can distribute you can distribute your dependencies. The other option is virtual env, which is nice, but it's Python only. I would like a solution that also works with R, and frankly, I'd like a solution that works with, C++ and C too. Anyway, so I think Docker would be my vote to be the solution to that. Any other questions? I have like 2 minutes left, so one or two more.
Python 2, it's mainly a dead project. What about the support for Python 3?
Oh, Python 3. I love Python. I love Python 3, man. Don't get me wrong. I love Python 3. It's just like I need stuff to like support it. Like once everything supports it, I'll move over to Python 3, but I don't have a strong opinion. I'm okay with Python 2. It's better than Java, as far as I can tell. In terms of writing, I mean, I know it's a low bar, not to dig at the Java guys. I write Java too, but I think that Python 3 will, once it gets more support, it will be very usable. But it's the same thing if you look at some of the alternative Python interpreters, right? PyPy, where you have. It's blazing fast, but it doesn't support NumPy, so I can't use it, right?
What package are you seeing
If they all support it, then we can run Python 3. That's fine. For this, I use Python 2 because it seems to be the lowest common denominator.
mainly the blocker seems PySpark. We are working only on Python 2.
Yeah, so I think PySpark only works with Python 2. I think that is
But
true.
I think this is the main question. Why?
I'm sorry, what was the question?
The main question is why PySpark is working only on Python 2.
Oh, only on Python 2? Oh, I mean, I don't know. Probably because someone just made that decision. They figured there was the lowest common denominator, and there wasn't a ton of there wasn't like a huge push for it. I would love it to work on Python 3. Hell, it could work on Python 4. I'd be happy. I have less than 1 minute, so I think I'm going to close it down. Any other questions you have, you can come up to me afterwards. I'm accessible. Thanks.